Good morning. New video for 3E notes over linear programming. Talked about this a little bit in class on Tuesday. Linear programming, first and foremost, is going to involve a system of inequalities. It's going to involve a system of inequalities. So something that we shouldn't already know, we should already know how to do. Again, 3D and 3D part 2 have all that stuff in there. In linear programming, we want to use graphing, and really whenever we're doing a system of inequalities, the best thing to do is just to graph them and follow the process from the 3D notes that we sort of went over there in order to get your graphs, get your points where they intersect, and then shade above, below, wherever we need to shade. No different here. Next thing, what we're going to do once we graph the system, we're going to find our corner points, and we can do that directly on Desmos. And so even though it says, using substitution, elimination, or graphing, really graphing is easy because we can just click on the corner points and we have them. What the system of inequalities is going to represent, it's going to represent our constraint functions. Our constraint functions. And so our shaded area is really going to be the area that sort of constrains us. I'll talk about what that means here in a moment. The other function that we're going to have is the objective function, which is the thing that we're trying to maximize. The objective function is not going to be part of our system of inequalities. The objective function is not going to be part of our system of inequalities. Our system of inequalities is basically going to tell us, okay, what are we constrained by? And our objective function, we're going to plug into our corner points to find, okay, given what we are constrained by, what is the maximum that we can try to get? I actually want to do a word problem with this underneath here first before we do some simple math problems, because I believe that the word problem will probably help us understand this concept just a little bit more. We did one in class yesterday, but let's just do another one to put our minds at ease here. Sorry, getting ahead of ourselves. So when we find the corner points of our constraints, we'll plug those coordinates into our objective function to determine the maximum value. Jump the gun a little bit. Okay, so a company manufactures two types of printers, an inkjet printer and a laser printer. So I'm going to make inkjet X and laser Y. So the company can make a total of 60 printers per day. 60 printers per day. That should give us our first function. X plus Y equals 60. Or X plus Y is less than or equal to 60, I should say. We can make 60 total printers per day. It has 120 labor hours per day available. It takes 1 labor hour to make an inkjet, 3 labor hours to make a laser. Okay, so again, this is something that the company is constrained by. So 1 labor hour to make an inkjet, so 1x, 3 labor hours to make a laser printer, so plus 3y, and we have 120 labor hours per day available, so that's going to be less than or equal to 120. The profit is $40 for inkjet, $60 per laser. How many of each type of printer should the company make to maximize its daily profit? This here is our objective function. So because we're trying to maximize profit, everything in here is our objective function. So the objective function is just going to be our total profit, which we're trying to maximize. And it's $40 for inkjet, so 40x, and then $60 for laser printer, 60y. If you want to hold off on doing the objective function till later, that may not be a bad idea as well. But just know what our objective function is and sort of separate it from the rest of the functions that they give us. The rest of the functions they give us are our constraints, which is over here. So the company is constrained because it can only make up to 60 printers per day, and it has 120 labor hours per day available. Okay, so this is what limits it. So what we got to do with our constraints is we're going to make a system of inequalities. So we have to make a system here, and in order to do this system, first we got to get x by itself. So when we have x plus y is less than or equal to 60, we minus x, we minus x. So our first equation, y is going to be less than or equal to 60 minus x. Our next equation that kind of got all screwed up here, 1x plus 3y is less than or equal to 120. Again, let's get the y by itself, so we'll minus x and minus x. And then we'll divide everything by 3. So we minus x over here, cancel that out, divide by 3, divide by 3. So y is less than or equal to 120 minus x all over 3. All right, so we have our system of inequalities right here. So now what we're going to do is we're going to graph these and find our corner points. So we go to our Desmos, and we're going to use the Desmos star one. And remember, we cannot use inequalities of these. We got to change it to equal. So we'll just change these signs to equal. So y equals 60 minus x. And then the other one is y equals 120 minus x all over 3, I believe it was. Yeah. So here's our two graphs. There's our two graphs. On both of these graphs, again, if we go back to our thing, we had y was less than or equal to, we had less than or equal to 60 minus x there, and we had less than or equal to 120 minus x there. So on both of these graphs, we're going to shade underneath. So we'll shade underneath the red and shade underneath the blue. Now, we don't have to do both. If we're smart enough to sort of shortcut this, we can. So what ends up happening here is our constrained region is basically going to be from here to here to here to there to there. So that's the area where the inequalities overlap. So far, this is what we did on 3D and 3D part 2. We write the equations, solve for y, get y by itself, graph them, shade in our region, and we really don't need to shade our region in here because most of the time our constraint region is going to be sort of underneath the two graphs. May not always be, but I would say for the most part it will be. And now we just want to find our corner points. So we obviously have a corner point at 0, 0. And we have a point at 0, 40, 30, 30, 60, 0. Zero, 40, 30, 30, 60, 0. So these are our corner points. These are the max points. So 40, 0, 40, 30, 30, 60, 0. So since we have our three max points, so we have 0, 40, 30, 30, 60, 0. What we're going to do is we're going to plug these 3 points into our objective function here to find out what combination of printers will maximize our profit. So if we go 0, 40 right there, so we'll go 40 times 0 plus 60 times 40 into our objective function right there. 40 times 0 is 0, 60 times 40 is 2400. So if we do 0 inkjet and 40 laser, we'll make $2,400. $30, so let's try that. So we have 40 times 30 plus 60 times 30. 40 times 30, 1,200. 60 times 30 is 1,800. So that would profit us $3,000. Then our last max point, 60, 0. So 40 times 60 plus 30 times 0. 40 times 60 is 2,400 plus 0 is 2,400. So again, we're trying to maximize our profit. So our point of maximum profit is going to be here, 30, 30. 30, 30, what does that mean? Well, we said our X value was inkjet printers, our Y value was laser printers. So to tie all this together, erase some of this stuff here. In order to make the most amount of money, given that this is the amount of money we make on this thing here, we want to sell 30 inkjet and 30 laser. Okay, 30 inkjet, 30 laser. Given what we are constrained by, given that we can only make 60 in a day, and given that we have 120 labor hours available, this combination of printers will make us the most amount of money. All right. So look at some of these easy problems here first. I just want to look at number 1. So number 1, the work's already kind of done for us. And so that's sort of like 1, 2, 3, and then 4 and 5, we have to do a little graphing. But so if we're looking at number 1 right here, we have the point 0, 7, 1, 0, 8, 0. We want to find the minimum and maximum values of the objective function. So on number 1, the objective function is x plus 2y. We already have the max point, so we have 0, 7. So we can go 0 plus 2 times 7. We have 1, 0, so 1 plus 2 times 0. And then we have 8, 0, which is 8 plus 2 times 0. Plugging that right into our objective function right there, which is x plus 2y. So 0 plus 2 times 7 is 14. 1 plus 2 times 0 is 1. 8 plus 2 times 0 is 8. So if our objective function being x plus 2y, okay, 0, 7 gives us 14. So this will give us our max. All right. And then 1, 0 gives us 1. So that'll give us our minimum. Okay, so on this one, the graph's already done. The corner points are already done. That's why we don't have a word problem or anything like that. So since we already have our corner points, which is what we're really trying to get, we're trying to get our corner points to plug into our objective function and then use our objective function to calculate all of our possible maxes and mins. Okay, so try